When we build software, we don't start from scratch. We stand on the shoulders of giants by utilizing libraries and remote services that are specified by APIs. In this episode, we'll talk about application programming interfaces, APIs, what they are and what they do. Welcome to Kopec Explains Software, the podcast where we make computing intelligible. This episode, we're going to be talking about APIs, application programming interfaces.
In the most basic terms, what is the purpose of an API?
In the most basic terms, an API is a way for one piece of software to talk to another piece of software and request that some kind of action be completed. It might be that you want some data to be processed. It might be that you want something to be done on the screen. It might be that you want to have some information retrieved for you. It could be anything. But this is something that a programmer will use. As a user, you're going to use software that was programmed using APIs because APIs are the way that one piece of software interfaces with existing software, and we never build software today completely from scratch. We're always building software on top of libraries or resources that are other software.
We're going to broadly put APIs into two categories, local and remote.
Yeah, let's start with local. So local APIs are going to be those that interface with libraries that are already on the machine that the programmer is programming for.
And what do you mean by libraries?
A library is a set of pre-built software functionality that a new piece of software can call into. In other words, there might be functions in that library that do something useful, and instead of you having to write those again yourself, you can just take advantage of the fact that somebody already wrote them. So a library has pre-built functionality that a programmer can take advantage of to build on top of. And a lot of libraries come built into operating systems. Anytime you program a modern app, whether that be for iOS or Windows or Linux, there's going to be libraries that come with the base operating system that basically everybody is going to utilize to make their app. Let me give you an example on iOS. If you're building an iOS app, you're going to need to show buttons on the screen. You're going to need to show text boxes. There's a built-in library on iOS called Cocoa Touch. And basically everyone who writes an iOS app today uses the Cocoa Touch library. It's also known as a framework. Some libraries are also known as frameworks in order to build their app because they don't want to go reinvent the wheel. They don't want to go rediscover how to build a button. So instead they use the button off the shelf that's already provided by this library that's built into the operating system. Now, some libraries are built into the operating system. Other times we find libraries that we're going to specifically include just with our app. Let me give you another example. Let's say I'm building a chess app, and I'm really just interested in the user interface. I can find a library that already knows how to generate legal chess moves, how to do a search for what's a good move in any given position, and I can just bundle that library into my application, and then I can just concentrate on maybe building a chess database or building a user interface for people to play against the functionality that's in the library. But I don't have to go rediscover how to generate legal chess moves or how to search for positions. Instead, maybe someone else has already built this library. I can download it, include it as part of my app, and take advantage of all that pre-built functionality. So generally, local APIs are going to be either those that are from libraries that are built into an operating system or that are libraries that you're specifically including in your app because you need that functionality.
So what about remote APIs? How do those work?
So when I talk about remote APIs, I'm talking about APIs that exist on a different computer from the computer where the program is running. Let me give you some examples. So maybe you want to utilize the Yelp API. Now, Yelp is a great place to go to search for local restaurants or businesses, find some reviews, right? Maybe you want to build an app that also is able to do something with restaurant reviews. Maybe it does something that the Yelp app itself doesn't do, but you need all that data that Yelp provides. Well, Yelp provides an API which anyone can hook into who registers for a developer account with Yelp that allows you to actually search through their big database of all the restaurants out there and look at all the different reviews. And the way you would use this is you would actually create a little message, and we'll talk about the encoding formats a little bit later, that says, hey, here's the type of restaurants I want to search for. You transmit that message over the internet to Yelp servers. Yelp servers process it and send back data over the internet to your application. Now, that is actually a type of API. That might be that the functionality is not in a library in the same way that it is for a local API, but it's still an interface between two pieces of software. It's just the way that that interface works is not that you're directly hooked into it in the software that you're writing. You're instead having to transmit a message, and then the way that that message needs to be formatted is what defines the interface. So the way that that message is composed is going to include some very specific parameters, and the way that those parameters are ordered and the way that they need to be formatted is specific to the Yelp API. And if you followed that specification correctly, then you can make use of this software on another machine. And so each API has to have a specification that's really clear that programmers can follow. And that's true for both libraries, but also for remote APIs as well. Let me give you another example. Maybe you're building weather software. Well, Apple just came out with an API called WeatherKit. Of course, there's a million other weather APIs as well. But maybe you want to include Apple's weather information inside your app. To do that, you're going to call Apple's WeatherKit Remote API. And again, you're going to have to format what you're looking for, your query, in other words, in a very specific way that Apple has specified for WeatherKit. You'll transmit it over the internet, and then they're going to send you back the data in, again, a very clearly specified format. And when we utilize an online API, we don't necessarily know the details of how it's implemented on that server that we're connecting to. So we don't know how Yelp behind the scenes is handling our requests. We don't know how Apple's WeatherKit is handling our requests. We just know how we have to format the request and how we can expect the response to be formatted.
So what you're talking about is how the requests are transmitted.
Partially. I mean, it's both how it's transmitted, which has to do with what protocol is used, what format is the data encoded in, and then it also has to do within that the specifics of how the literal query, the actual, and it's usually going to be a text format, so the literal text, what it looks like. So it's both how it's transmitted and also how it's formatted.
And what are some of the protocols that are used?
Yeah, today the term remote API has almost become synonymous with web service. The reason being that most remote APIs are accessed over the same protocol that we use for browsing the web. And we have a previous episode about how the web works that goes more into these protocols that I'll link to in the show notes. But when you use your web browser and you connect to a web server, you use what's called the HTTP protocol, or the secure version called HTTPS. It stands for Hypertext Transfer Protocol. And this is the same protocol that we use usually today for connecting to remote APIs or web services. Then there's another part to this, which is how the data is encoded for being transmitted on the HTTP protocol. And there's two main formats. The more popular one today is called JSON, J-S-O-N, and the older one is called XML. And we did a previous episode on XML, so I'm going to link to that in the show notes too. It's kind of too much for us to go into the details of how JSON and XML work, but they are standard ways of encoding data for transmission over the internet and actually also for local data as well. Then within using one of those two formats, so we're using JSON or we're using XML, there's also very clear specifications for any API of what the actual request that's encoded in those formats needs to look like. So what are the parameters of the request? How are each of the keys and values that we're looking for having to be specified? Everything is specified to a T. So it's very, very clear what the server is expecting from us when we want to utilize an API. And also very, very clear what we're going to get back. Remember, the key word in application programming interface is interface. This is a layer between two pieces of software. And for that layer to work, it has to have a clear specification so that we know how the two pieces of software are going to talk to one another.
Can anyone use these APIs? Like, are they free?
Yeah, it varies quite a bit. I mean, for anything you can think of on the internet, from an app that embeds Google Maps to an app that connects to WordPress for a blogging app, or an app that uses Yelp or something like that. These are all different APIs run by different companies. So it varies a great deal. Most large companies usually offer free tiers for their APIs, and they might be limited in some way. They might be rate limited, which means you can only do a number of requests in a certain amount of time. Some of them are just absolutely limited, so you can only do so many requests per month. And usually there'll be a tier that you can pay for if you need more functionality than that. Now, some companies make their entire business model around providing APIs. Some companies, this is just a value-added service that expands their platform, expands their developer base. So if you're something like Yelp, right, you're making most of your revenue from actually having people post advertisements that exist within the Yelp app. And having an API is generally just to expand your platform. So most people using the Yelp API are not paying anything. So it really depends on what the specific API is and the specific company's business model. A lot of great functionality is out there existing for free for developers to take advantage of. Sometimes you'll find that there's a really niche API that a company can have a really good business just doing. I'll tell you a really weird one. I came across a few years ago. There are free APIs for getting the latest news headlines if you're trying to build a news app. But there's actually a company that sells an API just for really, really high quality news results. And they're able to form their whole business just around being the service for people who want to make apps centered around the news. So there's a great amount of variety in the API space, but there's tons of stuff out there for free to experiment with.
Can two different places implement the same API?
Absolutely. And I'm going to talk now both about local and remote APIs. Absolutely. Anybody can go and implement the same specification. This was actually a point of controversy, though. There was a big legal case last year that it actually was going on for like a decade called Oracle versus Google. And we did another episode on this, and it also talked about APIs. So I'm going to link to that in the show notes. But the case actually went all the way to the Supreme Court, and it was all about if you have an API, even though the software underneath it, remember, it's just an interface, might be different, can somebody else go and create the same exact API? And again, they might have a different implementation under it, but can the interface be exactly the same? Can you copyright the interface? And the decision in the Supreme Court was no, you can't do that. And if it had been the other way around, it would have invalidated a lot of pieces of software because re-implementing APIs is actually very, very common in the software world. Let me give you a great example of this. A very popular API re-implementation in the Linux world is called Wine. What Wine does is it actually re-implements the Windows operating system's base APIs. Why would you want to do that? It's so that you can go and take a piece of Windows software and actually run it on Linux. It's a pretty amazing thing. And Wine is actually open source, and there's been decades of work put into it. And it actually works pretty well. But if you couldn't re-implement APIs, Wine would be illegal because it would be violating Microsoft's copyrights on the Windows APIs. A lot of the software industry actually depends on the ability to re-implement APIs. But remember, we're talking about re-implement, even though the interface itself might be the same. So that's just the specification of how the two pieces of software talk to each other. The underlying code that actually makes that functionality real can be totally different. And it should be, because that is illegal. You can't just go and copy somebody else's software if it's not in the public domain or under a license where you just have to give them credit, for example.
How important are APIs to a programmer?
Yeah, again, and I should remind everyone, APIs are not something that users interact with. They're something that programmers interact with because they want to make use of functionality that already exists in another library or in a web service. So APIs are critically important to programmers today. Everything we build is built on top of libraries and web services. We're not reinventing the wheel. We're not going to go reinvent Google Maps. We're not going to go reinvent a restaurant database. We're going to take advantage of the Google Maps API or the Yelp API. When we're writing software for a specific operating system, we're not going to go reinvent how to do a button. We're going to use Cocoa Touch on iOS or the Windows API on Windows. Every piece of software today stands on top of at least some APIs, and a lot of software stands on top of a lot of APIs. And some people say today, actually, there's a saying that learning to program on a new platform is 20% learning the programming language that is used on that platform and 80% learning the APIs. Let me give you an example of what that might mean. Let's say you're learning to program today for Android, right? Modern Android development is generally done in the Kotlin language. But what this phrase is saying is that 20% of learning how to program for Android might be learning Kotlin, and 80% is actually learning the APIs that are built into the Android operating system. So you're going to spend a lot more time wading through all of those APIs. And by the way, in Android, there are thousands and thousands of different APIs. And that actually might be a lot more difficult and a lot more of your time, assuming you already know how to program in another language, than it is actually learning Kotlin.
So how does a programmer really learn APIs?
Like anything in programming, has to do with a lot of practice. These APIs are so in-depth. We were just talking about Android, right? Android has so many different APIs. It's so complex. The only way to get good at it is to get some experience with it. And once you've spent months and even years working with some APIs, you'll become very good at them. You'll have your own kind of pre-built functionality that you've built on top of them that you can reuse, your own libraries that will have their own APIs, if you will. And just like anything in programming, it's just about sticking with it and spending the time and doing the work. Learning APIs today to become a software developer is basically as important as learning new programming languages.
So overall, APIs really are this foundation of modern programming.
Right. They're the way that two different pieces of software talk to one another, the specification for the layer between two pieces of software. And that other piece of software can either be local, it can be a library right on the same machine, or it can be remote. It can be a piece of software running on a server somewhere that you're just accessing to get some data or some action completed for you. And basically anything you want your software to do, there's probably an existing library or remote web service to do it. So you're using APIs all the time when you're building modern software. The amount of functionality that actually exists outside of the new software you're building versus the amount that you're actually building from scratch is likely going to be quite a ratio. You're actually going to see that you're utilizing a lot more functionality that's already pre-built by other people than you are writing yourself from scratch. So APIs are critically important to all software that's built today. Thanks for listening to us this week. Rebecca, how can people get in touch with us on Twitter?
We're at Kopec Explains, KOPECEXPLAINS.
I want to remind everybody to leave us a rating on your podcast player of choice. Don't forget to follow us. We have a lot of followers now on Spotify and Apple Podcasts. Appreciate every one of you. Drop us a line. Tell us a topic you're interested in us covering in the future, and we'll see you in a couple weeks.
Bye.